Right, hi everybody. Good morning, afternoon, or good evening, as usual. In this video, we move on to topic 7, and topic 7 is called climate change and energy production. Topic 7.1, which I'll begin with this video, is called energy choices and security. Now, I didn't think we could really look at choices and security without first of all looking at what options for energy production are actually available. So in this first kind of preamble to topic 7.1, I wanted to just look at the different types of energy resources that are available for use by humans. Okay, so I picked out or cherry picked a few things from the syllabus that's relevant. Only 2 or 3 statements really. So first of all, the IB syllabus says that fossil fuels contribute to the majority of humankind's energy supply, and they vary widely in the impacts of their production and their emissions. Their use is expected to keep increasing in order to meet global energy demand. Then it says sources of energy with lower carbon dioxide emissions than fossil fuels include renewable energy. You can see that for yourself, and their use is also expected to increase. Now, somewhere between the classification of a non-renewable source, fossil fuels, and a renewable source of energy is nuclear power. Technically, it's non-renewable because it will run out eventually, but there are potentially millions and millions of years of supply available to humankind. Under applications, it says we need to evaluate the advantages and disadvantages of the different energy sources. Now, I don't know if I'll go into all of these details in this video, but really what I want to do is to compare non-renewable energy sources to renewable energy sources and maybe dip into the idea of evaluating advantages and disadvantages of each of them. So above my head you can see that I've put a list of renewables and a list of non-renewables. Remember that the list of renewables includes what we should call replenishables. Replenishable resources are non-living. And under non-renewable I've put coal, gas, oil and nuclear. Okay, so let's just go through a few points about the energy that's available. This is the same list pretty much as you can see here. Under renewables and or replenishables, I've got solar, hydroelectric, geothermal, tidal and wave power I've put, and then in the middle you can see I've got biomass and biofuels. We could really put that all together under the title of biomass. I've separated it because you can see that biomass could be used directly by burning wood, which makes up a huge source of supply of energy in LEDCs actually. Biofuels are separated because what you can do is with any kind of biomass, any kind of plant material really, you can ferment it with yeast basically or under industrial conditions, and you can turn it into a alcohol which can then be burnt as a fuel, and I've called that a biofuel. Under non-renewables, fossil fuels, so called because they actually come from fossilized plants or animals, are coal, gas and oil. And then separate to that, because it's not a fossil fuel but it is a non-renewable resource, technically is nuclear power. Okay, so very quickly, some what I would say are interesting facts about energy I've just researched. In 2019, although the figures vary quite widely actually because they're all an estimate, I found a couple of sites that estimate global energy production at about 8 times 10 to the power of 19 joules of energy, which might not mean a lot to you, but it's a huge amount of energy. About 80 to 85% of this in 2019 was derived from the burning of fossil fuels directly, coal, oil and gas. And humankind has become dependent on fossil fuels, and I think there's a few reasons for that. One, it was the original fuel that powered the Industrial Revolution. Originally that was coal in Britain. And because of the infrastructure and the technology that developed directly from the Industrial Revolution, we've become dependent on fossil fuels and the infrastructure that we've created to support it. Oil has some advantages, which I'll look at a bit later in some detail. but it's plentiful, or it might be running out. Um, it's very, very portable, which is a big advantage, and you can readily distill it into other things like petroleum, gasoline, or other fractions like kerosene, which is jet fuel. Um, when the combustion engine came along, not long after the not too long after the Industrial Revolution, we became really dependent on fossil fuels as our means of transportation and power. Okay, I'll move on from that. Um, what I'd like to do in this part is just link um, where fuels are used and what places of the world in which fuels are used. So you can see on this map, it's a little bit out of date, but it corresponds to per capita energy consumption per country. And it's pretty obvious that the most energy per capita is used in MEDCs by far, and the smallest amount of energy per capita is used in LEDCs, specifically in sub-Saharan Africa. Another interesting graphic here. There's a fairly strong correlation, I would say, between GDP, gross domestic product, or how rich, a measurement of how rich a country is, and how much energy is used per capita. This is in kilowatts. This on the y-axis is GDP, and you can see there's a pretty obvious correlation. Poor countries, small energy use per capita, LEDCs, low energy use per capita, MEDCs, high energy use per capita. That's fairly obvious. Okay, and then finally, just to finish off this video, I think what we'll do in the classroom is look specifically at energy resources, specifically the different types of renewables, and look at the advantages and disadvantages. But I've just put a few ideas together to guide us. I want to look at renewables, then fossil fuels, and then nuclear. And then we can go into more detail later. Right, so for renewables, well, the obvious advantage that you'll know, even before we start this topic, is that renewables don't release greenhouse gases. In the case of biofuels, that's not quite true, and that was the reason I separated it. If you burn biofuels, you still produce carbon dioxide, but by definition, biofuels are carbon neutral. What that means is all of the carbon that you put back into the atmosphere by burning that fuel has originally been taken out of the atmosphere by photosynthesis in the first place, by the plants that you processed into the biofuel. Okay, another big advantage is that they don't release nitrogen oxides and sulfur oxides, which cause acid rain. That's a big problem with fossil fuels. And in general, the use of renewables has a fairly small footprint, ecological footprint. The exception to that again is possibly biofuels, because you need a huge area of land to actually grow crops to ferment into your alcohol or your biofuel. Incidentally, I did another bit of research, and currently the two biggest countries in terms of production of biofuels are the US. The US is number one, and Brazil is number two. The US generally they grow corn and turn corn into the biofuel, and in Brazil generally sugarcane, very productive crop. Obviously, a big problem in Brazil, the number two producer of biofuels, is what land is actually used to grow that crop of sugarcane. In a lot of cases, it involves deforestation of the Amazon to provide land to be able to do that. Okay, disadvantages of renewables. Generally expensive. Part of that is because it's not a technology we've become dependent on in the same way we have with fossil fuels. So there's still a reluctance in some ways to invest and be the first people to use renewables. As I've said, there are some technologies are still being developed, although that's becoming less and less true. They're becoming more and more efficient, and there's more and more of a driver for industries and individuals to switch to using renewable resources. And then finally, locations might be limited due to conditions, politics, or reluctance of people to want to live near some sources of renewable energy. So in a lot of cases, people don't want to live near wind turbines, for example. Um, I don't believe it, but some people see them as an eyesore and they block landscapes. They can be noisy. They might kill wildlife, but they don't, as some politicians recently would have you believe, seem to cause cancer. Okay, so that's just a very brief overview in general. Fossil fuels, I've already mentioned some of these before. Cheap and plentiful, an existing technology that we're already dependent on. Um, Oil, especially, and gasoline is portable. It can be transported over long distances, therefore. Um, and I've put at the end that, in general, no other sources are able to produce as much energy. At the moment, I believe about 80% of all of the energy we produce on Earth is from fossil fuel sources. Only about 20% from renewables. Right, and the obvious disadvantages of fossil fuels: they're polluting in terms of greenhouse gases, carbon dioxide specifically, nitrogen oxides, sulfur oxides. By definition, they're unsustainable, so therefore eventually they will run out. Supplies are limited. We're becoming more and more ingenious, I think, at extracting the last drops of oil from oil resources. For example, fracking. And as resources diminish, it becomes more difficult and more dangerous to extract them from the ground. Obviously, they can cause accidents, specifically because they're so flammable. In a lot of cases, especially coal, we've become dependent on open cast mining, which means we destroy huge amounts of landscape to be able to mine those resources in the first place. Right, and then finally, as promised, nuclear power. Well, the obvious advantages are no greenhouse gases, no nitrous oxides or sulfur oxides. They're actually a very established technology. Nuclear reactors have existed since the 1950s. They can produce huge amounts of energy, and despite the fact that I've called it a non-renewable resource, it verges on being renewable because it will never really run out during our lifetimes. Very, very efficient in terms of the amount of energy that is produced per kilogram of fissile or nuclear material. And then the obvious disadvantages. Nuclear reactors produce waste that we haven't really solved the problem of how to dispose of yet. In some cases, it involves dumping at sea and hoping that the oceans dilute enough for that waste not to be dangerous. The US stores its nuclear waste in basically mountainsides where they've hollowed out mountainsides in order to store it. If you've seen the film Godzilla, you'd see that there's some problems associated with that. Obviously, radiation exposure and accidents can lead to cancers and very severe health effects. And it's an expensive technology. Uranium is scarce, exists in some very poor LEDCs where those resources and those people are exploited for access. Planning and safety is difficult, long, and complex. Okay, so that's a very, very brief overview of renewables, non-renewables, a very brief, again, evaluation of their advantages and disadvantages. And I think we can go into the next video now with a bit more of an understanding of what energy resources are actually available for exploitation. All right, take care everybody, and I will see you in our class.